go, hey, it's elastic like that. No.
Good morning, Matt. How's it going today?
Good morning, Ryan. Doing well. How about yourself?
I'm doing well. So, servers. How do you like servers? Do you like taking care of servers, feeding them, patching them?
Yes. Wait a minute. Oh, no, not at all. They're like children. I like to ignore them as much as possible until I'm, legally required to do so. So,
Absolutely. Yes. So, a lot of customers think about going to the cloud. They think about just moving stuff that they have in their data center, right up into our data center. And there's a lot of services that we have, and to be able to make that transition easy, and remove the element of management from the backups and patching and keeping things to the latest patch level with things like SQL Server, which we'll talk about today.
Oh, good.
And we have with us Mike, who's done
Welcome,
some work
Mike.
with. Yeah, welcome. A peer of ours that has done a lot of work with a customer of his. In particular, in maximizing some value that they can realize with using our SQL PaaS, or actually, I guess I should say, software as a service. It would probably be a better clarifying way to describe it. So, why don't you talk a little bit about what you do for Microsoft, and then we'll dive into what you did with your customer.
Great. Thanks, guys. Thanks for having me on. So I am a cloud solution architect with Microsoft, just like you guys. I've been at Microsoft for about 2.5 years now, working with a bunch of different clients. And today we'll talk about one I think is a really good, interesting story. Prior to coming to Microsoft, I worked in Azure for several years as well. So I worked on Azure kind of on both sides of the table. And really excited about the cloud. I think the capabilities and the advancements in the cloud, really even in just the past 6 months to a year, have been just absolutely amazing. So very excited to talk about this today.
Great. Well, we look forward to hearing it.
Yeah, right. Yeah, absolutely. All right, let's get started. So Mike, we have this capability in Azure called SQL Azure DB, and by itself is a hosted database platform that customers can leverage as a receptacle to house any relational database that they might have on premises, and eliminate the need to have to manage servers. So why don't you talk a little bit about how that equates to what you did with your customer and how they took advantage of some additional capabilities we have with that called Elastic Pools.
Yeah, great, thanks. Yeah, so this customer is really looking to maximize their value. When they came to us, they had a new product that they were starting to sell out to their customers, and when they came to us, they had about 400 customers, and they were looking to and seeing some real big growth in this product. And interesting part of the architecture is every customer had their own database. So as you can imagine, as they continued to grow and as they were starting to really have a sales push, the number of databases is going to grow a lot. They wanted to go from these hundreds to thousands. And as you talked in the intro, every one of these databases needs to live on a server. That server needs to be purchased, racked. It needs to have the OS installed, has to have SQL installed, and the database needs to get created. And by the way, it's not just one database and one server. They need to talk about HA and DR, and I have multiple databases, multiple servers. And looking forward and looking at their sales projections, while they were really excited about, hey, this product is great and it's really, really going to grow, they also got really scared of how in the world are we going to possibly manage all this as it grows.
Were these separate instances, or were these was this like a huge instance with a lot of databases?
This is, well, we'll talk about how we SQL Azure it works, but each one had their own database. So if you think about from a programming perspective, right, your connection string, you had your server name and a database name, and every one of them was separate.
Oh, that's going to be awful.
And as a SaaS provider, as they make changes to their product or changes to their schema, there's not only the complexity of rolling this out, but then there's the management aspect of it. Yeah, we remove servers from them that they have to patch and maintain, but they still have to manage all their schemas, and that's a lot of connection strings to manage.
Can you imagine, though, the SQL upgrades alone, that at some point, they'd probably never touch it,
Exactly, right? I mean, when you get to thousands of databases, and so you get the SQL upgrades, but then think about when you need to do a hardware refresh as well.
Oh, no, yeah. You're just curious how big the servers were. Yeah, no kidding.
Yeah. So obviously, again, they're really excited about the sales and really about the growth in the product, but obviously very nervous about the maintenance. So they kind of came to us with these goals, say, these are the things that we need to be able to do. How can you help us? Right. So they want exponential growth because they see this product really, really taking off, and it was really popular. But at the same time, they can't have a linear growth of staff. Right. I can't have thousands of servers managed by hundreds of DBAs. It's just is not a scalable approach. So how do we do that without really growing our staff? And then obviously we talked about the hardware installations and the software installations and the maintenance of all that. It just becomes completely untenable. They also need to be able to accelerate onboarding of customers. So as you can imagine, as they needed to grow the hardware and grow the databases, they had some automation built in, but at the same time, they were building or looking forward to building a database server a month. And as they're going to continue to grow faster and faster, every 3 weeks, every 2 weeks, right? It's just something they really couldn't manage. No. And then so they were actually going to get to a point, they're projecting to get to a point where they couldn't build servers fast enough to onboard the clients as fast as they needed to.
Well, I know who was really happy about this model was the software licensing guys from SQL. Man, they must have had a great time, great year for that one, right?
Well, and the salespeople for this customer, because it's great that they're growing, but this is a perfect example of a customer that needs to digitally transform because the traditional ways of doing things just don't make sense when you start scaling like this.
Well, I'm thinking about the capital outlay just alone in hardware for that type of scale. The CFO must have been pulling out his hair or her hair because that's, to your point, there's just no right answer for this.
Yeah, the storage vendors are probably their friend.
Oh, no kidding, we won't name names, say, right?
Right. Okay. I think not only think about the servers and the databases and the DR sites for all that, but we'll think about the backups as well, right?
Oh,
how do you manage the backup? And he likes to talk about the storage. The amount of storage you're going to need is to exponentially grow even faster than the number of servers you need. So,
sure.
A big problem. And then, of course, you got the reliability and resiliency. So you're managing all these servers. What happens when you need to do patching? How do you manage downtime? All this stuff is just an absolute nightmare. And then
were they? I got a quick question. So were they, from a DR perspective, were they thinking about always on availability groups is a possibility? Because I think a lot of people go, I'll just do this, but they still don't understand that that's just typically a couple of nodes in a cluster, but that really doesn't solve the burdens that are up at the top part of your list too.
Yeah, so they were using always-on clusters. They had synchronous replication to a secondary data center, which that's where we get to kind of the reliability and resiliency is their second data center wasn't that far away.
Let me say, was it like a couple miles down the road? Yeah.
It was far enough away that if there were a localized flood, you'd be okay. But if there were, now where we are, hurricanes aren't really a problem and earthquakes aren't really a problem. But if something were to happen, there was risk. There was risk that perhaps they shouldn't, they needed to get rid of.
Okay.
And then last bullet there is every business is how do we lower our cost?
Right.
And they measured cost by client. How much does an individual client cost us to run? All right, that helps them with their pricing, but also, hey, how can we get that lower so we can make sure that we're as profitable as possible? Right. Okay. So those are the goals they came to us with. And as we've already teased, we presented them Azure SQL Database as a fully managed platform. No servers for them to build, no maintenance for them to have. All the security updates and patching, Microsoft takes care of. Another interesting, great thing about it too is backups. We talk about the backups and the storage. SQL Azure Database automatically backs up for you. It's continual. You don't even think about it. You turn a database on and it's already getting backed up. And let's talk about the different tiers and your ability to restore. It's pretty compelling.
So now some people would say that's not real true SQL. It's like, because we can't do that on premise. How are you doing at Microsoft? What's the special pixie dust that you've done in your service here? So do we have a little bit of an understanding of the architecture and like how we pull this off?
Well, I mean, we pull it off because we are a massive cloud provider. So, we have built in the automation and the tooling, and we have the whole platform underneath it. When you look at the how we release SQL today, Features first go to Azure SQL in the cloud. So we release to the cloud first, and then those features get pushed to our on-prem box product, if you will. So there is good parity from the relational database perspective between the two. So there's no special secret sauce. As a matter of fact, we'll talk about a little bit later. When you're running SQL Azure, there is really no change you need to make to your application to whether it's running on-prem or in SQL Azure.
Okay, so all good.
Yeah, so we actually went through that transformation that your customer is going through now, or actually has gone through, in driving down our cost of our services, so our customers can benefit, because we too didn't want to exponentially expand our support team and our operations staff. So it was built at scale to be able to handle that sort of the types of applications or workloads your customer wanted to roll out. So
this is good dog food. We ate our own dog food and we like it. All right, good.
Yep.
Now I've heard it also. We drink our own champagne.
I've heard it called
Kool-Aid. That's better than dog food.
Hey man, this is a kid-rated show, okay?
Yeah.
Okay. Sorry.
Yeah.
So one of the things we needed to kind of get them past is, hey, if we're going to have all of this customer data in the cloud, how do we know that it's secure, right? It's a classic story. Hey, my on-prem, I have my moats and I have my firewalls and I know that I'm secure. I don't want to give my data away. I don't want to put it in the cloud. Well, Microsoft, we believe that your data is your data. It's not ours, right? We're not going to use it at all. And in Azure SQL Database, we've made sure that we have, all the controls and constraints around that, with always encrypted. It's encrypted at rest. It's encrypted in transit. We have all of the different security measures that you'd expect on the on-prem product with row-level security and data masking. All those are available as well. We also have threat protection, so we can see when the traffic to your database is abnormal and alert you to that as well. So if somebody's trying to get to your database, it's not supposed to, we can identify that as well and alert you and let you know, hey, this is somebody's trying to get in here. There are firewalls in as well.
I too work with a software vendor that is in the finance space. So data store, the types of data they store is particularly important to their customers, of financial nature. And certainly their customers, if there were any sort of exposure of that data, that would be a disaster. So for them to invest in hardware and other services and DBAs to implement some of this themselves shouldn't say cost prohibitive, because they certainly could have done it, but leveraging our service to be able to offer all of these capabilities, it literally was a checkbox for some of their SOX, compliance that they had to go through, and even they themselves have FedRAMP certification. So this was the data storage was literally a checkbox. All of these features you just mentioned, addressed all the demands of some of these compliance protocols.
I heard a rumor floating around that somebody demoed this product at one point and left SA and password on and turned on the threat detection, and it didn't get hacked. That the security was so good that it prevented that from occurring. So I thought that that's a great rumor, or that's a really great story. So any truth in there?
Haven't heard that, but boy, that's just a bad idea. So
yeah,
let's not that. Let's not test it, okay?
That's what I'm doing.
All right.
Another thing we offer as well is we have Active Directory security just like you do on-prem, right? So users and groups log in. You don't have a proliferation of SQL, SA, and admin, SA and passwords is there as well. So full security on that, and so that really helped them kind of, like I said, check that box. We're good to go from that perspective. And so when you look at, so we kind of sold them in the fact that, hey, there's no hardware you need to be installing, all that patching is all taken care of. But then what else can we offer? Well, when you work out of the database on-prem today, you'll run SQL Profiler every once in a while to make sure your indexes are good and make sure your execution plans are great. And when you have an issue, something's not performing well, you have to go and triage that and figure out what happened and what's going on. In SQL Azure, we have something called a database advisor, which is constantly looking at the telemetry and the metrics coming out of the databases and looking for bad or missing indexes, bad execution plans, and it will alert you to say, hey, here's an index that you might want to have, and you can click a button in the portal to go and add it, or even better, and this is something my customers just started implementing, is let it do it for you. So you don't have to wait for it and look and go and manage it. You just let the database manage itself, add indexes and execution plans and so on.
China has arrived. This is AI-based DBA.
It is, yeah. I mean, it really, really is, and so it really kind of takes that troubleshooting work away. You don't need to worry about it. The cool thing about it too is, when a profiler or something might recommend an index, hey, go and apply this index, you're going to see an improvement. It wasn't always as effective as the profiler might have thought it would be. And Database Advisor looks at it and says, okay, I'm going to apply this index, and I'm going to look at it over time. It starts really quickly, the half hour, an hour window it is, I think. It says, did that index get the performance improvement that I expected? And then it's going to keep looking at it over several days. And if it sees any regression or doesn't see the improvement it expected, it'll roll it back for you.
Oh, nice.
So it goes both ways.
So carrying this over to your customer, were these capabilities compelling to them to enable? And if they were, how did they do this previously? Did they just have an army of DBAs that were just watching this constantly, and or do they just maybe hope for the best and wait for the customer to complain and kind of react?
Seems to be a lot of implicit trust coming into this kind of conversation.
It really was mostly reactive. So there's performance issues. We go look at it and say, oh, here's here's an index we might be able to add. The developers will look at, hey, we're writing some queries that now are including some of these columns. Maybe we should add an index for it. So have that. And then from a execution plan, if the database got a bad execution plan because the table churned a lot or whatever, some different reasons you get a bad execution plan, they'd get it. They'd get an alert. They'd have to go into the database, go find it, and then go revert the execution plan. All that was manual. So being able to take advantage of the Database Advisor is a really, really big, compelling win.
Okay.
Yep. So now that we've convinced them that Azure SQL is a great place to be, a lot of benefits we talked about, now you got to look at it as well. Are the databases that we have, are they compatible with the cloud, and how do we get there? So there are a bunch of different tools on the screen here of how to get there, kind of based on where you start. So, what database platform are you using today? What capabilities you're using? So they were already on SQL Server, and so the Data Migration Assistant was the tool for them. And basically, this assistant said, "Yep, you're good to go. You're really just using the relational database engine, CRUD operations. Nothing special." So there's one thing to note in SQL Azure versus the full on-prem install. They're not. The feature compatibility is not one-to-one. So
because it's a PaaS or SaaS service, there's some capabilities that aren't available because it's running in that shared infrastructure that we just can't technically make available. However, I know that there's a tier that it does make those available, but the shared services aren't things like analytics. And SQL Server reporting services and that sort of thing.
Yeah, another thing is cross-database joins are things that you can't do in the PaaS offering. Right, we do have other offerings. So we do have a managed instance SQL offering, which is also PaaS-like, but has more parity with the on-prem capabilities. But they didn't have to worry about that. They were completely compatible. They were just a bunch of databases doing CRUD operations from their application. So migration, the cloud assistant said, you are totally good to go.
So using that migration assistant, how did that work for them? So now you've got an active portfolio of customers using their products, and they needed to move these databases over. Did they do it all at once? Did they kind of pick some smaller customers and trial with those? And how did they go about doing that?
We'll get there. So that's in a couple of slides.
Okay, good deal.
Yeah. So one thing you need to think about for databases in the cloud that you really don't think about on-prem is database sizing. So on-prem, you think, oh, I need a server with so many cores and so much memory. I'll put databases on there. I'll watch the metrics on that server, and as soon as I get to some threshold, I'll build another one. And you don't really worry about the databases themselves. Now, since in Azure SQL, the database is the thing, so there really isn't. There is the concept of a server, and the fact that when you look at your connection string, there's a server name. But that is really just a totally abstracted construct. There's no server that you build. There's no server that you maintain. It's just a bunch of databases associated with this server, this ephemeral thing. So the database is the thing. So you really need to look at what size database do I need to provision. And it comes in tiers and sizes. So there's 3 tiers: basic, standard, and premium. And within there's different sizes. The standard and premium are the production tiers. The basic is really more for dev test. And then within the tiers, you have the different sizes, and we measure those sizes in what they call DTUs, which is a completely new concept. So the question is, what is a DTU?
Okay, this is interesting to me because I get asked this question all the time. What the heck is this thing? And I'm like, I don't know.
Exactly. Yeah. So it is a cloud construct, right? It's not something you think of on-prem, and they get the AKA MS link there at the bottom. You can go to it.
Oh, perfect.
A lot more detail on this. Really, it's a combination of the amount of processing power, CPU you get, the amount of memory you have, and then the read-write I/O. So it's kind of a blended measure of that. And the idea is, since you don't have this server concept where you can physically measure the CPU and memory, and it's shared across databases, it's a way to put some constraints and sizing around a particular database. Mm-hmm. So on that link,
the neighbor problem and so forth. Yeah.
Exactly.
So one thing I should highlight too is that we do have a fairly new way to purchase that is based on, we call virtual cores and memory. Yep. So if that's actually, from a sizing standpoint, if that's an easier construct for customers, we do now have a purchasing model that allows them to do that. But it's not, I know at the time that your customer did this, DTUs were really the only option.
Yep. Yeah. And so the vCore option is currently in preview. Yep.
Yeah. So Mike, let me ask you a question here, because this is I think once people can kind of wrap their head around the DTU concept. And or if they're in the virtual core and the memory kind of things, I don't find that DBAs or my customers, I'll just use a broader stroke. Customers typically have a good handle on what their performance looks like. So it's trying to marry them up. And I think it's important to go back to those tool sets, those migration assistants, because they help us understand this better, right? Like, I'm not a DBA. And so for me to sit down and go, first thing I look at is memory pressure, CPU pressure, disk I/O. But yet that's moving in a constant phase. And I love this chart here that you're showing us where, there's this reads and writes and the different pressures that they put on the systems. That's a lot of science and, just kind of understanding about it, right? So I think it's important that people take away this, like, if you can't get your head around these constructs or if it's taking maybe time is your problem, right? Those migration assistants are key tools from us that help you get around this sizing the database right into our services.
I've talked to a lot of DBAs, and when you ask them how big of a server they need, well, I need a 128 core with 256 gigs of RAM.
I need the Maserati, darn it. But it's not going to pull your boat. I'm sorry.
You never ask an engineer how big a machine you need, because it's always going to be, I need the biggest.
Yes, exactly.
Yeah.
Now, we laugh because we've all said it ourselves too, I'm sure.
Yeah.
Right?
Absolutely.
How big of a machine do you got?
That's right. How much money you got? It's usually my answer.
I have a development machine I use in Azure, and it's a pretty darn big machine. It's bigger than any machine I'd buy, so why not, right?
Yeah, exactly.
It's available.
Yeah. Okay.
All right, so now moving to the cloud, how did they get there? Right, so the data migration assistant does have the capability to take a database and push it up and move it into Azure. By the time we got to this point, they'd grown from 400 databases to 2,000 to 3,000 databases. So remember, we're hitting a moving target, right? So they came to us when they had 400, and we're selling like gangbusters. Now they have several thousand. How do we get them up there?
Yeah, you're bored. Growing.
yeah. And And interesting too is from a timing perspective, they're getting to the point where if we don't really get this moving now, we're going to have to buy more hardware.
Oh,
So
wow.
we're quickly approaching their finish line before they need to buy some new stuff. So what they decided to do was first, let's migrate and move slow. Let's move a couple databases. And what they decided to do was, you know what, we're going to take a weekend when where these clients are not busy, and we're just going to take an outage for them and take backups and restore them in Azure. So nice and clean. Not worrying about trying to move a live active database, which you can do, but they decided, this is just going to be easier. We just have so many, let's try to make it as easy as we can. So they dipped their toe in and got used to it, and by getting a couple hundred databases up there, they're okay. Now we know how to manage it. We understand. The process is all smoothed out, and let's start moving a little faster and a little faster. They're able to work in that hybrid mode for a while. I think they were in 3 weeks or so, 3 weeks to a month for the full migration of all these databases, which is a real testament to how you manage and use these databases as well. As I mentioned before, the connection string for Azure SQL Database is really no different than if you're connecting on-prem. It's just the server name is now a fully qualified server name to the Azure virtual server that you have out there.
So can we take a pause for just a second? Because I want to draw out something you just said. You had a hybrid model here. So where's the front end for their app?
So the front end for their app
was it still on-prem, or was it also in? Ooh, I like your face here. This is gonna be good.
I'm trying to think timing perspective. So as of now, everything is in the cloud. At the time, they were moving the application as well.
Oh wow. Okay, so this I think. Okay, so there's another great story in here, but we won't go into that part. But I think that's another key piece. Is I've had customers who have tried this, data on-prem, front-end cloud, and then I've never seen one flip a little bit, but or have the I guess the kind of the courage to go try that stretch hybrid model where different components are living in different areas of their architecture. But that I think is also says something about our cloud's performance, right? For this Azure SQL to be able to respond to those connections. Nice. Okay. Sorry, I'll be quiet now.
Yeah, do they have a like express route connection in place, or were they just using the public internets to?
Oh yeah, this is.
Yeah, so they were for this they were using the public internet.
Wow, that's impressive. Wow.
Get out!
Wow,
that is too cool.
Yeah. So not to muddy the waters. We're here to talk about SQL, but they at the same time they were moving their application as well. And at points in time, they had a hybrid model where some clients were hitting the application in the cloud to databases on-prem, and some they were hitting the application on-prem to databases in the cloud.
Oh, wow. Yeah, but I mean that means Azure SQL is as good as anything you could build on-prem from a performance standpoint. Yeah. So I've had arguments with storage guys. Oh, cloud storage is not fast enough. Well, it is, because this is what's also fronting the back end of this guy. Right. I just have to make sure that Yep. All right. Sorry.
Yeah. When you boil the cloud down, it's network compute and storage.
That's right. That's right.
It's all the fancy stuff we put on top of it that makes it all the better. So nice.
That's slick.
Yeah, so they were able to do this, work in this hybrid mode for a while until they got everything migrated up. Again, no server builds. We've already talked a little bit about the HA. So SQL Azure is built in HA. So you build a database in Azure, and we take care of the HA for you. And from a DR perspective, it's really, click button DR. You decide what region you want to go to for your secondary, and then configure it there.
So customers ask then, what's the replication time around that DR? What's the transactional recoverability in this space?
So we don't have an SLA, and it really is going to depend. So it's an asynchronous replication. So it's the same if you had a async SQL server always on, which by the way,
this isn't down the street. This is like hundreds of miles away. So I think people understand. We put the risk
over a ridiculously fast network. So
we do. Yeah.
But you can't make light travel faster. So
well, I don't know, Ryan. I could try.
Yeah, so it's really going to depend where you decide your DR site's going to be. So whether you're going to go across the continent, around the world, right? So that's really going to depend on the latency.
We're not talking minutes here.
Oh, no, definitely
Yeah,
not.
we're talking
No.
like in the seconds
We're,
range.
we're
right?
yeah, we're still in the seconds, milliseconds range
Yeah,
of,
yeah.
of
Okay.
replication. Yep. Yep. All right. So as I mentioned before, they'd gone from 400 databases to now a couple of thousand databases, and at this point in time, they were really kind of cutting edge because, as we teased before about the Elastic Pools, they were not ready yet. So, with a lot of databases comes a great big price tag, and they knew this going in. This was part of the plan. They were going to be meeting Elastic databases at the front door when they were ready, and so what do Elastic databases do? Well, they are in the same way that you provision a database that has the DTU. An Elastic Pool is a container of what they call eDTU. It's the same measurement, it's the same thing, but since it's an Elastic Pool, they've had to put a little E in the front of it for Elastic DTU. And no matter how much you put into that pool has the same cost, right? So as long as you can put databases in there within the constraints within the constraints of the pool, it's more cost effective for you. And so that's what they were looking to do, is how would we then now go from this individual database model to this Elastic Pool model? And on this slide, I purposely left some of these databases as standalone to kind of highlight this is something that they are doing, because they do have some clients that are really, really big and very active, and it just made sense for them to leave those as standalone databases, because to put them in pools, that one customer would blow out the capacity of the pools. It didn't make sense for them to put them in a pool.
Oh, so is it kind of a concept of you could have a noisy neighbor inside the Elastic Pool that could potentially demand the resources of the pool?
Good.
Yeah, there are some tiers with Elastic Pool, or within the tiers,
Yep.
we have a maximum number of DTUs per database, but certainly you could have, if you have a number of large customers in their case running in the same Elastic Pool, you might end up bumping up against the total DTUs for the pool.
So it's still a police state. It's not the Wild West, but yet there are still the definitions and constraints. Okay, all right, I got you.
Yeah, like Ryan said, there's the concept of a maximum DTU that any one individual database can consume. Mm-hmm. So you can put a cap on that. Say, hey, you know what? I have a 400 eDTU pool. The max any one database can take is 50.
Okay.
So so they just can't consume everything.
Gotcha.
So it does get to the next challenge, which is kind of filling the pool. How do they fill the pool most effectively, right?
Yeah.
So if you look at a single database, it's really easy to understand and keep that one database in the right size, right? Because you got one data set to look at, make sure that those metrics are good. Filling a pool lightly packed is also pretty easy. So you put 4 or 10 databases in a pool. Again, it's easy to understand and look at those databases and understand, okay, they're fitting within the constraints and no big deal.
Yeah, but you talked about thousands.
Right. So the real challenge is, how do we pack them in nice and tight? Because again, the cost efficiencies come from a really tightly packed pool. Mm-hmm. And how do we get to that standpoint? And so what they decided to do was, let's take a stepwise approach. Let's start off simple and say, let's just go ahead and put them into pools. Not a whole lot of thought going into it other than, hey, we have the constraints in the pool, or currently were the size, the DTUs, worker threads, and session count. So let's take a look and say, let's go ahead and throw the databases in there. Some thought around it, but nothing scientific about it.
So how costly are the sins for not having a good structured plan ahead? Can we change the pool assignments? Can we start to move them around? How hard is that?
You guys you're just skipping ahead on my slide.
Oh, I'm so sorry. I mean,
it's okay. This is great though. So,
we're like sitting on the edge of our seats.
I'm like, let's go.
So the first step was, hey, let's go ahead and lightly fill the pools. So the second step is, let's balance the pools. So now that we've thrown them in there, let's take a look at the telemetry on those pools. So again, the 4 basic metrics: DTU, worker thread, session count, and storage. Those are the main constraints of a pool, and let's make sure we don't bump out on any of them. Mm-hmm. And so when I say they're doing that kind of the basic metrics, is they're looking at what's the max DTUs that these databases are taking? What's the max DTUs, EDTUs in the pools? And let's make sure if they get to 80, 90%, okay, now we need to start thinking about moving stuff around. Seeing things that work with those in session counts. So what they needed to do was take a look at those and then start being able to rebalance them. And this is an ongoing activity because as they onboard new clients, those clients might start small. The databases will grow over time, obviously, and the activity they might have might grow over time. So as they onboard the clients and those clients onboard their employees, they're going to have more and more activity. So the profile for a database on day one versus the 6-month period might be completely different as it grows. So looking at rebalancing is something that was very important.
So does a rebalance cause any type of outage to the customer at the back end of this? Right, so if we're moving them around, or they're right, I mean they're being aware of their operational SLAs to the customer, right, contractually.
Yep.
And it sounds like there's a lot of this great magic, this orchestration that we put on top of SQL and a lot of really awesome automation. It would be a shame that if you're rebalancing, we start creating a lot of disruptions.
Right. Yep. So there really is a very small disruption to the customer. So there's two types of rebalancing that you can do. You can do rebalancing within a server and across servers. Okay. So again, the server itself is this logical construct. It's not something that they manage, but moving, rebalancing on pools within the same server is really just kind of switching the billing model around.
Okay, fair.
And across servers, it actually does copy the data. So under the hood, what it does is it sets up a replica on the new server, replicates over to it, and then fails over.
Okay, I got
That's how it does it under the hood. Both of those, there's maybe a 5 to 8 second blip in the connectivity. So basically, it drops the existing connections and picks up new ones on the other side. So the same way you do a failover.
Okay, so no different that it could be covered in an operational maintenance window, obviously non-working hours. Okay, cool.
Yep.
And I was just poking around too on the pricing calculator from a cost standpoint, just to quantify some cost savings. When you look at an individual database size for a particular level of DTUs, it might be let's just use a rough number that I was just looking at, about $200 a month. But then you can put it into a pool that might be $800 a month, but you might be able to run with 10 or 20 customers in that.
Right.
So your effective cost, $800 is certainly much more than $200, but when you can put 10 of them in it, it's a huge cost savings. Yeah.
Right. Yeah. Well, imagine when you can fit 150 in one.
Oh, holy cow. Okay.
Right.
Yeah.
Yeah.
Something tells me you've tried that before.
Yeah. And if you balance them appropriately, it's not a problem.
Wow.
So kind of doing this rebalancing on these metrics, really got them to the point where, okay, now they're getting some really, really high efficiency on the pricing model. But they're not done because every project needs a little sprinkling of machine learning, right?
Mm-hmm.
And AI. So
you seriously use machine learning to do this?
Oh yeah.
That is awesome.
So this is where they are now. They're just starting to implement this machine learning process. So the old process was, let's take a look at the max DTUs. Let's take a look at the max values, right? And spread around about that max value. But that max value might have been, at a particular time during the day or one time during the week. And that was just that peak then. And so they're not really looking at really effectively filling these pools as best they can. So now using machine learning, what they're looking at is a time series analysis. So these different databases, the activities peak at different times. And let's go and create kind of this, we call anti-correlation. So let's make sure if we can pack them in so they're gonna peak. They might peak beyond what you would normally feel comfortable with.
Opposite times of the day.
Oh, that is so cool.
That is really cool.
Okay, so I just want to say, so I can already hear questions in from people who are going to be watching this and going, I don't know if I can do that. That sounds really complicated. So Mike, if you can take 30 seconds just to help us understand how much work, how much effort and investment did they have to get here to this? But because it just sounds so cool and almost easy. But I mean, surely it's not easy.
Right.
Yeah, help us with this.
Yeah. So the old approach was pretty easy. They'd collect the telemetry and look at maxes and figure out, okay, we need to move these guys around. This is complicated. They do have a data scientist working on it. They've worked through different machine learning algorithms to do it. As you can imagine, as they continue to grow, the amount of data gets exponentially more as well.
Sure. But the payback here that I can just already see, I can see business guys, the CFO going, yeah, this makes sense, right? Because it's optimization to a zero decimal that's not even registering probably. Right. But also the fact that now the customer experience in the back end has to be, just amazing. Right.
And if you look even farther forward looking is they get more and more telemetry over time, they can identify customers that maybe they have a big summer season. So let's go and make in advance of that happening, let's go and make sure they have extra headroom, or customers that are big retailers that might have a big Black Friday hit or something. They can go and proactively move these into pools that have more headroom because we know, hey, tomorrow they're going to just completely spike, and if we left them where they were, they might blow out a pool and start getting throttled, right? So
this is really cool. I've just never thought about using machine learning.
I know, right?
Infrastructure balancing. That's
hey, now I want to be a DBA.
Yeah, that is really cool.
Yeah.
So to quantify that, so you said that earlier they went from 400 to 1,000. Like, how many are they at now? Like, are they managing roughly? I mean, are we talking tenfold of that, or I mean, is there pretty significant growth? I'm assuming so. If they making the investment in a data scientist in these processes, I mean, that's got to be a huge ROI for them as that quantity grows.
Right. So remember when they first came to us, they had about 400 customers, so 400 databases, and they're currently at 20,000.
Holy cow. Okay.
So, yeah. Wow. So think about that's actually 40,000, right, with their DR site as well. So it's a lot of databases.
Yeah, it is.
A lot of databases.
Cow. Okay.
It's working out really well for them. So can you imagine how many servers they would need to have built?
Oh, yeah.
It's just, I just like give up now. Okay.
Yeah. Mind blown.
So one of the things I wanted to make sure they could do, right? So not only can I have these servers out there, but I want to be able to monitor them at scale, right? I need to make sure that I know that they're healthy, and I need to be able to get the data that feeds into that machine learning algorithm. When they first started, so they've kind of come along this journey with us. Like I said, they started getting all these databases before Elastic Pools were available, and they started getting a lot of these. They need to be able to monitor before we really had some of the telemetry available to them. So what they ended up doing to start was they created automation accounts and hybrid automation workers and pulled the data out of the databases. So pulled the metrics out of the databases, put them into a telemetry database, and then looked across that database to be able to do the rebalancing. Since then, and this is what they're implementing now too, is getting that data. The SQL databases themselves emit a lot of telemetry, and so instead of doing a pull, now that data and all that telemetry can get pushed out into our diagnostics. And what they're looking is they're getting it pushed into Event Hub, and they're doing the classic, cold and hot path telemetry analysis. So the cold path is let's go to get all that telemetry and use that as our rebalancing mechanism. That's the big pool of data, long run of data.
Yeah.
Yep.
Yeah.
And then the hot path is they have a unified monitoring system that all applications need to be able to alert out of this one system. So now they're able to take, looking to get that data through Event Hub into their alerting system. So for hot paths, so if we know if they have a database that's going off the rails, somebody ran some query that they shouldn't have, they can get alerted for that right away. In addition to that, the amount of data and the type of data they can get is a lot more. So they've been looking at really 4 pieces today, and there's like 12 here now that they can look at. So they can get very, very fine-grained in their monitoring as well. So it's a lot of improvements in the platform have kind of come along, and they've come along that journey with us, and as a process of seeing huge improvements in their operations. So it's kind of review and say, hey, you know what? They came to us with these goals. and I think we can both say that we met them, right? From an operations staff, when they started, they had 2 DBAs and 400 databases. They have 20,000 databases and 2 DBAs. So
I think that's mission accomplished right there. That's
yeah.
That's awesome.
They haven't bought any hardware at all. As a matter of fact, they were actually able to shut down the colo that the servers were in. So both the databases and the application servers that were running that colo are now all decommissioned. Onboarding new customers, they have it fully automated. So when a customer sales rep sells a new customer, they can go into the admin portion of the app, click a button, and the database is automatically provisioned and pre-populated for them. So there's no activity whatsoever needed for there.
That's why they're able to. So making an investment, that's important because a lot of customers are turned off by looking at some of the automation aspects. And it's a lot of work. I'm working with a customer right now that was just the other day that was talking about that. And so this is some upfront effort that's going to save you an immense amount of pain down the line as you grow.
It's an investment in your business. And a lot of people see IT here lately is that's not part of my business. It's a necessity, right? And the evil necessity. But really, IT needs to be part of your business strategy as well. And it sounds like these guys get it.
Yeah, that's cool.
Yeah, and you asked at the beginning, right? How does Microsoft manage this at such scale? And the answer is automation. Right. You can't have people do all this, and you certainly can't have the SLA levels that we have if a person needed to fix it.
Right.
The automation needs to detect the problem and correct it itself in order to hit the SLAs. And that gets us to the reliability and resiliency numbers, greatly improved. They were at 98% or so availability, and now they're at 3.5 nines.
Holy cow! So their costs went down. They were able to grow without growing their team, and they improved their SLA, and that's an awesome story.
Yeah, that's a huge win.
Yeah, and we brought their cost per client down significantly as well. So it's significantly lower than it was on-prem.
Oh.
Yeah.
So from an operational standpoint, we met all the goals, and like I said, it was a journey for both of us as our platform improved and as they were really pushing the boundaries. They were a really great partner to work with us and make sure that they actually helped drive the product team, right?
Oh, good.
So it's something that hey, we need these features to really be effective and to hit these operational goals, and the product team absolutely came through and partnered with us and them to get there.
So, Mike, you didn't specify a specific timeline, but are we talking years? I wouldn't think, but are we talking 6 to 12 months?
It's been probably 1.5 years from the very beginning.
Okay.
Yep.
But that I would see, a lot of people need to understand is in a transformation journey, but all the activity that happened just in that year, in 18 months, and looking back to your presentation, that's a lot of activity. That isn't just, we're waiting.
It's not just a lift and shift story that they just set it and forget it. No.
Yeah.
They move, they optimize, they continue to optimize. So,
Yeah.
Yep.
Wow.
Yeah.
It's a great story. Thanks for sharing that.
You're very welcome.
So, Mike, thank you very much for coming on and showing us what you did as a CSA to help a customer transform their business. That's a fantastic story, and I think a great testament to some of the work that our CSAs are doing with customers and certainly what you've done for your customers. So thanks a lot for coming on and walking through. That's actually the goal of the show is to take complex concepts like DTU sizing with elastic pools and highlight how a practical customer can actually take advantage of some of these capabilities to literally transform their business and drive down costs.
Yeah, great job.
Great. Thanks for having me. It was great to share, and hopefully some other customers can take advantage of this as well.
All right. Yeah. Thank you very much.
Thanks, Mike.
Thank you.